In the last part of the video showing how to run a motion analysis on a Formula SAE car's suspension system, the post-processing will be looked at. There are three main ways to use a motion study. The first way is to plot various values within SolidWorks Motion. Select the XY plot icon at the top of the Motion Manager. Here, a number of categories and subcategories can be selected and plotted versus time or other results. To create a plot showing the displacement of the damper rod during the motion study, first select the main category of Displacement, Velocity, Acceleration. Choose Linear Displacement in the Y component. Select the face of the damper rod and choose the rest of the shock absorber to define the coordinate direction. Once the green check mark is selected, a graph will show the displacement of the rod. Another way to use the motion study is by using the motion data with SolidWorks simulation. When using motion with simulation, only top-level parts can be used. If there are other parts that you want to run simulation on, you'll need to dissolve the subassembly before being able to run simulation on the part. There are two different methods of exporting motion results to simulation. First, it is necessary to add in SolidWorks simulation by going under Tools, Add-ins, and selecting SolidWorks Simulation. The first way to use SolidWorks simulation with motion is by clicking the icon in the Motion Manager for Simulation Setup. Here you can select a top-level part that you wish to analyze. Then choose the time frame that you are interested in, which in this case is the time where the tire hits the hole. Under the Advanced tab, you can set up your mesh density. Once set up, the simulation can be run by clicking the tab to the right of the simulation setup. Make sure that material is applied to the parts. Running simulation through the Motion Manager reduces the control the user has on the simulation, so if more refinement such as mesh controls are needed, you need to export the motion study by going under Simulation and select Import Motion Loads. Select the motion study that you want to use as well as the part that you want to run simulation on. Choose either a single frame or multiple frames. In this case, we'll look at frame 55, which is during the time the tire hits the hole. Click OK and then open the part that you selected. Choose the study that is created at the bottom of the SolidWorks screen. Make sure to apply material and any other boundary conditions to the study. Once run, stresses, strains, and displacements, as well as many other parameters, can be looked at. The final way to use the motion study is to optimize your model. Sensors need to be added first in order to create the goals of optimization. In the model, right-click the Sensors folder and select Add Sensor. There are a variety of different sensors that can be used in optimization. For this case, we'll look at reducing the displacement by changing the spring constant on the shock absorber. In the Sensor Property Manager, select Motion Data, Motion Study 2, and then the plot that corresponds to the linear displacement graph of the damper rod. Insert a new design study by going under Insert, Design Study, and then selecting Add. In the window that appears, click Add Variables. Add a parameter by selecting a dimension or other parameter that you would like to optimize. Enter Spring Constant as the name, and under Category, choose Motion. Select the spring from the motion study and then choose Spring Constant in the component link. Select Apply and close the window. In the Design Study Manager, change the drop-down next to the variable name to Range. Enter the range for the spring constant, which in our case is from 20 to 40 newtons per millimeter. Under the Goals heading, select the Displacement 1 sensor and choose Minimize. Make sure Optimization is selected and then choose Run. Once completed, the optimal design will be shown in green. This new design can then be used to run another simulation study if desired. The design study can be used to optimize a vast number of different parameters, and this is just a simple example to show how to go about setting it up.